Okay, so today we start embarking on all the fun, which is trig identities. And I know that trig identities can be challenging at some time. I know when I was in high school, I definitely had trouble with trig identities, but I've since learned a couple of strategies on how to do these better, and I hope to share them with you. Okay, the first and foremost is your attitude towards trig identities is huge. Okay, if you go in with an attitude that you can't do these things, you probably won't. But if you have a positive attitude about how you go off and try and figure these things out, then I think you'll have much more success. Treat it like a puzzle. Okay? If you think about how you first learned as a kid to do puzzles, you learned strategies. You first open up that box and you see tons of pieces there and they're all rearranged and it gets very overwhelming. We can do that same idea with these trig identities. You look at the question, it looks really overwhelming. But the first time you went and solved a puzzle, your dad or your mom or an older brother or sister or something showed you some strategy. So what's the first strategy when you solve a puzzle? You go off and you find all the corners and the straight pieces because you know where they go. So that's a strategy you learned. And now every time you go to do a puzzle, you already have that strategy at your disposal and you go off and do it. So, and then you go off and you go around and do the outside of the puzzle. So you learned that. And then maybe, that worked well and it got you some of these simple puzzles, but then you got more complicated puzzles and you needed more strategies other than just that. Well, same with trig identities. Last year in grade 11, you started doing trig identities. Now you're doing grade 12 ones. So we're going to learn from what we did in grade 11 and build upon it. So back to the puzzle, maybe you learned, you look at the picture on the puzzle and there's a big red balloon in the puzzle. So now you start going looking for red pieces because you know that those ones are going to fit together. So again, you learned this strategy and you go off and apply it. Sometimes it works, sometimes it doesn't. With trig identities, it's the same idea. Every time we do a question, we learn some new strategy that we can use the next time. And if you learn enough of these, you start to get good at it and you'll have more success. So here's some of the strategies, and this is on the bottom of the worksheet, so you don't need to copy this down. But here are some strategies. So for starters, when you do trig identities, remember you're going to work with the left side of the equal sign and the right side separately. Excuse me. So you can't have them equal to each other because you're trying to prove that they're equal to each other. So you separate them and you look at the left side and the right side. You do manipulation on either the left side or the right side. You can't bring them both. I mean, you can do both, but you can't bring them across the equal sign. Number 2, change everything to sine and cos. It's a lot easier to do this. So if you see a trig identity with tan in it, change it to sine over cos. If you can change it and put it in common things, it's easier to show that the left side is equal to the right side. Next, remember your algebra rules when rearranging. So rainbow works, collecting like terms work, all these things, even factoring works, and we're going to do one with factoring. Replace certain identities with other more simpler ones, if possible. So if you're doing a trig identity and you got sine over cos sitting there, maybe you're going to change that to tan. Or if you got sine squared plus cos squared, you're going to change that to 1. It makes it a lot easier. And then finally, sometimes in these big complicated ones, you have these fractions. Common denominators are often a possibility when you're dealing with fractions. So if we go to grade 11, we started off with some simple trinomials, and that's what we're going to start with today. Or sorry, simple identities. That's what we're going to start off with today. And there was a couple that we had at our disposal. So the one that we had at our disposal is tan theta, or tan x, doesn't matter. It's equal to sine theta over cos theta. So if you ever see tan, you can replace it with sine over cos. Might make it easier, or vice versa. The other one that's important, sine squared theta plus cos squared theta equals 1. So if these are from last year, and any variation of this is possible too, and I won't write them all down because they're on the worksheet as well. But for example, if you see a sine squared, you can replace it as a 1 minus cos squared. That came from just taking the cos squared and bringing it over. So that might be a strategy. If you're going off and you're trying to make the left side equal to the right side, and the left side has sines and the right side has coses, maybe you change sine squared equals 1 minus cos squared. Or of course, cos squared, I could have moved the sign and make it 1 minus sine squared. Okay, so all those are helpful, and those are ones that are on your worksheet. We're going to learn tons of more. but that's where we can start. Okay, so our first one then is this. And then you'll notice that the title of this is Trig Identities Review. For the most part, these are all questions you would have done in grade 11, but I thought it was best if we just spend a day reviewing the ones that we should be able to handle before we get into the grade 12 ones. So this one, I want you to prove this trig identity. That means I want you to show the left side is equal to the right side. The left side is 1 over 1 minus sine squared times sine squared, and the right side is tan squared theta. So let the supply teacher decide if you want to pause and give everyone a chance to try it on their own. There are going to be 8 that we're going to do today, so we don't want to spend too much time pausing, but I'll let you go from there. And then I'm going to go off and solve it when you're ready. So first things first, we must separate these into left side minus right side. Okay, I don't want to have to take marks off because you forgot to separate into left side and right side. You must work with them separately. All right, let's go off and use some of our strategies. Excuse me. So one of the first strategies that I talked about is put everything in sine and cos. Okay, might make things easier. So over on the right side, I see I've got tan squared. So tan is sine over cos. So tan squared is sine squared over cos squared. Now I don't know if I can go any further on that side. I might be able to, but I'm going to leave it right there because I'm previewing all the time. Like I might work with the left side, I might work with the right side, I might work with both. I'm previewing what I need to do. So I look over on the right-hand side or the left-hand side, and I see that I've got a bunch of sines. So the fact that I changed tan into sine is good. Okay. All right. So let's look on the left side here. I'm multiplying. Pretend that this is sine squared over 1. So when I multiply fractions, I multiply across. So sine squared theta on top. On the bottom is 1 minus sine squared theta. So 1 minus sine squared theta sounds familiar. And if I start comparing these, notice that they're starting to look more and more alike. See how the tops are the same. So now it's just the bottoms. Can I somehow make the bottoms the same? Well, that's when I recognize that that sounds familiar. 1 minus sine squared theta. Where's that from? It's right here. Remember, sine squared plus cos squared equals 1? So here, 1 minus sine squared is equal to cos squared. So this bottom, top stays the same, sine squared theta. The bottom is cos squared theta. And look what I got. The left side equals the right side. So therefore, left side equals right side. And it is proven. Now, the beauty about trig identities is there's a variety of different ways to solve this. Here's one method I just showed you. I changed the right side a little bit, changed the left side a little bit. Now I got down to the left side and the right side are the same, and so it's proven it. You might go a completely different route. So for example, and you don't necessarily have to erase anything, I'm going to go back a few steps. I'm going to go back to this step. Actually, even further. Let me go back to this step here. Okay. So I could have taken this. Remember, my first step was to change tan into sine over cos. Now, maybe I did this. Maybe I could have done this. And I said, compare the right side and the left side. Look at this side. I got a sine and a cos. But over here on the right side, all I've got is sines. So one strategy might be saying, hey, in order to make these the same, is there a way that I can change the bottom? I got a cos squared. Is there a way I can change the cos squared? Well, sure. Cos squared is equal to 1 minus sine squared. So why don't I leave this top here as sine squared theta, and why don't I move the bottom to 1 minus sine squared theta? So there's the strategy. And hey, guess what? Now the left side and the right side only has sines. That's a pretty good strategy. Now I'll go over to the left side and say, hey, this looks really familiar. Okay, this is sine squared. Okay, it goes on the top. The bottom is 1 minus sine squared. And guess what? Now, left side equals right side, and it is proven. So our solutions may look a little bit different, but they both are equally good. Last thing I'm going to stress here are these two last little bits. Once you get down that the left side does equal the right side, then you're going to write that down. But that isn't what I asked. I asked you to prove the trig identity. So you now have to write this line, and it is proven. All right, let's try another one. So again, we've learned some strategies. We're going to apply it, keep them in our toolbox, and then move on. So second one, again, I'll give you a chance to pause if you want to try it. But I'm going to go off and answer right away. All right, so again, I must separate it. So the left side is cos x, tan x over sine x. And again, this time I used x, last time I used theta, same thing, doesn't matter. The right side is 1. So there's not a lot of manipulation I can do on 1. So I'm just going to leave that as is. I'm going to look at the left side. I remember back to my strategy sheet. One of my strategy sheets is to change everything into sines and coses. It's easier to work with. So I remember that tan is equal to sine over cos, so I'm going to replace that. Tan itself is sine x over cos x, all over sine x. So at least I don't have 3 different things, a sine, a cos, and a tan. Now I only have 2 things, a sine and a cos. All right, on the top, I notice I have cos x times sine x cos x. So the cos x is like cos x over 1. And the sine x over cos x is just normal. So on the top, I'm going to treat the top like its own little question. I'm multiplying these fractions. So I'm going to multiply the top and multiply the bottom. So if I multiply the top, I get cos x sine x. I can't really combine those because they're different. And on the bottom, I have 1 times cos x, which is just cos x. And now I see I have a cos x on the top of this small little fraction and a cos x on the bottom, so that's going to simplify. That'll leave me with sine x on the top over sine x on the bottom, and anything divided by itself is 1. And so even though I can't see it because it's off my screen, I have the right side is equal to 1. So I finish off by saying, therefore, the left side equals the right side, and it is proven. Now, a couple of things. I'm pretty confident that some people probably saw the step from here to here in their head. They just looked at this and said, okay, that's cos x over 1. And it's being multiplied, and you could have canceled here. Totally fine. And gone straight to that. Okay? What I don't want you to do is do this. So at this stage say, oh, look, cos and cos cancel, and then sine cancel, and then right equals 1. That's a little bit too much that you're doing in your head. Remember, your trig identity is to prove that something is equal. Part of a proof is to be convincing. And part of a convincing argument is to be nice and clear. So by me just scratching at all these signs here, just scratch, it's not very clear what cancels. So I'd like you to sort of back up the truck a bit and slow that down. You don't have to necessarily slow it down as much as I did. But definitely here, you see how I canceled these. I didn't cancel the signs yet. I just left that and wrote this line down next. That way it's very clear that in this step, the coast is canceled. In this step, the coast is canceled. And now it leaves me with this. Now I can go off and cancel and get to 1. Okay? So there's a nice balance here between being convincing and clear. Okay? What I don't want to see people do is just go, oh yeah, cancel, 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 and then be done in 1 line. You might not have to have like 5 or 6 lines like I have here. You could shorten that up a bit, but don't shorten it up too much.